Hi, I'm Miss Hearn. Let's get started.
Okay. Now, it's important to note that not all functions have inverses. And there you might wonder why, because certainly you can switch all the x and y coordinates for any function that you want to. And that's true. However, when you switch the x and y coordinates of all the points, you might not get a function. Remember, functions have to pass the vertical line test. So let's look as an example. We're going to look at the function y equals x squared. I've plotted the three normal key points. I'm also going to additionally plot 2, 4 and negative 2, 4. So what would happen if I tried to switch all the x and y coordinates of this graph? What would the resulting graph look like? Well, if you switch 0, 0, it's still at 0, 0. You switch 1, 1, it's still at 1, 1. If you switch 2, 4, you're going to be at 4, 2, which would be about here. If you switch negative 1, 1, you're going to be at 1, negative 1, which would be about here. And if you switch negative 2, 4, you'll be at 4, negative 2. So we get a graph that looks like it's been reflected across the line y equals x, but it's not a function, which, by the way, would have the equation x equals y squared, because we've switched all the x and y's. X equals y squared is not a function because it fails the vertical line test, right? The one x value 4 matching up to 2 and negative 2. All right, so why did that happen, that it's failing the vertical line test? It's because the original function had the characteristic that if you drew a horizontal line through it, that you hit more than one point. So the original function fails the horizontal line test. I don't know if you're going to be able to read that. Let me write it with a different pen here. Okay, HLT, horizontal line test. You can draw a horizontal line and hit more than one point. That means it fails the horizontal line test. And that means that it does not have an inverse. Now, a function that passes the horizontal line test is called a one-to-one function. An example of a one-to-one function would be y equals x cubed. So y equals x cubed, I can actually draw a horizontal line anywhere I want to, and I only hit one point. So that means this passes the horizontal line test. And since each x value matches up with only one y value, we say there's a 1-to-1 relationship, and we call the function a one-to-one function. And if it's a one-to-one function, then it has an inverse. Okay, so we're looking at a function that has an inverse. What would its inverse look like? So if you can imagine drawing the line y equals x through the graph, it's going to be symmetric across that line. If you switch, by the way, all the x's and y's here, you still get the same 3 points, because those 3 points are all on the line y equals x. But what would its inverse look like? It would be turned sideways like this. And you might recognize that's the function cube root of x. X cubed and cube root of x are inverses, which makes sense, right? Because one function undoes the operation of the other. Or another way of thinking of it is if I gave you f of x and I asked you to find its inverse, what would you do? You'd do the 4-step process, and you'd say y equals x cubed, switch the x and y's, x equals y cubed, and then solve for y. To solve for y, you would have to take the cubed root of both sides, and you would get y equals the cubed root of x, which you would name f inverse of x equals cubed root of x. So this is some vocabulary you're going to need to know. You're going to need to know what the horizontal line test is. You're going to need to know what a one-to-one function is. And you're going to need to know that in order to have an inverse, a function must be one-to-one. So summary of facts that you need to know about what I'm going to refer to as invertibility. So we say that a function is invertible if it has an inverse. A function has an inverse if and only if the function is a one-to-one function. The graph of a one-to-one function always passes the horizontal line test. The horizontal line test says that if you can draw a horizontal line through a function and it hits more than one point, then the function is not one-to-one.
I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video. In our next video, we'll be looking at finding the inverse of a rational function.